I'm asked to solve the equations graphically, including a sketch, rough but accurate sketch, and marking the intersection point. So let's look at each one. Part A, I have the cube root of 2x minus 1 equals 5. So if I'm going to use the graphing method, then I'm going to use y1 as the left-hand side and y2 as the right-hand side. So if I go into my y equals, I'm going to clear out whatever is there. In this case, I need a cube root function, which is item 4 in the math menu, 2x minus 1, and then move my arrow to end the radical, go down to y2 and enter 5. I'm going to check my window, make sure I'm starting with the standard window. There's nothing about this problem that would indicate I need to change that. So let's see if that's going to give us a picture of the intersection. So the cube root function is there, and the output of 5 is here, but looks like it's way over on the right-hand side. So now my image here tells me that I'm going to need to change my window, and I'm going to need to make my X max bigger. So let's try 50. I'm going to hit graph again. So there's the cube root function. There's the 5, but we're still not crossing. So I'm going to take my X max up to 75. See if that gets us a nice cross there. Intersection is good. Somewhere here. So I'm going to say second calc 5. And I'm going to press enter then 3 times until I see the word intersection here. So the intersection is at 63, 5. So let's draw a representation of that graph here on our paper. So what I've really got, and I could have drawn this actually way over here, but I've basically got this, and then here's my y equals 5. This is going to be kind of a mess, but you get the idea that the intersection is 63, 5, meaning that the solution to the equation is x equals 63. So be very clear on the process here and what's going on. I'm trying to solve the equation, so I'm entering 2 functions into my calculator to see where they intersect. The x value of that intersection is the solution to the original equation. All right, let's take a look at part B. I've got 41 plus 5 times the square root of 2x minus 4 equals 11. So let's go to y equals, clear what we have there. And again, I'm going to enter left side as y1 and right side as y2. So I've got 41 plus 5 times the square root 2x minus 4, and my radical, go down to y2 and enter 11. Now on my window, I'm going to go ahead and graph this again on a standard window, even though I know from some of these values that I'm going to have to make some changes. But I want to get an idea of the direction I need to go. So I'm basically not seeing anything in the standard window. So let's take a look at our functions and see what's going to need to change. First of all, if I want to see this output of 11, then my y max has to be at least 11, or I won't even see that. So let me change that to be, actually, that would, if I was going to do 15, then that would get us this part. So let's try that and see what happens. So there's the 15, and let's graph and see what we get. Okay, so there's this part. I'm still not getting this part, but what's happening here is that all of my outputs, whatever happens here, I'm adding that to 41. So I'm actually going to need to make my y max quite a bit bigger if I want to see what's going on here. So let me take that up to 100, and I'm going to go ahead and take my x max up to 50 just to see if I can broaden out this window and get some idea. Okay, so there's the radical part. Here's the 11 part, and notice that they don't cross. This starting point here is the starting point for the domain of this function, so there are no values for this radical function to the left of that. It's only going to be increasing. This line will never be changing, so the lines never cross. So let me just draw kind of what we have here. And then the radical part is that, and the y equals 11 is here. They do not cross, meaning there is no solution for this particular equation.